Hello everyone, and good to see so many participants in the workshop. This is a workshop, and it's going to be conducted by Rupesh Labade. And am I pronouncing it right, Rupesh?
Yes, correct.
Okay, and he's going to share with us different activities of learning science at home during pandemic. I think it's going to be a set of 3 to 4 different live experiments, which he's going to share with us. So over to you, Rupesh. We can start the workshop. If there are any questions or anything, you can put it in the chat box. Yes, over to you, Rupesh.
Yes. Thank you, Katan. And we will start immediately. First of all, I will start my presentation. So can you see my slides?
I can see your slide, yeah.
Okay, thank you. Okay, welcome you all once again in the Global Hands-on Universe Conference 2021. Since we are doing this conference, this is our second conference in pandemic. And last year, I also took a workshop in this conference related to mobile apps, from which we can perform various types of laboratory experiments, which are very good for students. And now this time we are facing this pandemic longer and longer time. Our theme is also related to that. So learning science at home during a pandemic. So we can see in this picture, all students are in their houses, and just they can go in their balcony and not beyond that. Okay, parents are keeping them in their houses and protecting them against the COVID situation. And that's why they are just using their mobile for taking lectures or attending lectures. So they are little bit techno savvy, or we can say they are going frustrated by using this mobile also. And they are facing more physical problems related to eyes, related to their behavior. So we think that what can we do for for all students, because this pandemic situation is spreading worldwide. So what can we do for them? So we think that all the experiments or the concepts which are teaching in the teaching in the classrooms, we can perform it in our home also by using some simple material which is available in our house or nearby shops which are available. Or we can say that this kind of shops are everywhere. They're in maybe a rural area or maybe a city area in all over the globe. So we today in this workshop, we basically selected some of these experiments, and we perform it here. So I have already spread the material list to all of you. I don't know how much of you have brought this material with you. So we will go on because we have limited time. So first of all, I will also introduce my organization, that is Inter-University Center for Astronomy and Astrophysics, IUCA, which is a astronomy research institute in India. And in this institute, our SciPop department is there, which run all the outreach related activities in astronomy and the basic science in rural as well as urban area of all over India. So, first of all, we introduce what is the situation. So we all know about this. I will not going through this all the things because we all know, we all have faced this situation. So there is nothing to tell you that more than this. Okay, but this thing is very important, that education during this pandemic is totally get destroyed. All the teachers are at home. They are also facing so many problems, that how we can we are teaching through our Zoom live sessions or anything, Google Meet sessions or online sessions. But most of the students, instead of students, parents are attached to mobile. They are giving the answering. They are attending this workshop or any kind of lectures. So students just sitting in front of mobile and doing homework, and just through the all day they are just sitting in front of mobile, and mobile, or we can say computer, etc. So they are facing so many physical problems due to lack of physical activities that we always took in the school sessions. That is various types of games are there, various types of experimental sessions are there, various types of observation sessions we took in the school. And this during pandemic, all these things are get stopped. Yeah. So that's why we have decided that what we can do for this. We have designed some experiments. We can think that there is much more things in our house that we can learn from it. There is much more things around our house that we can learn from it. So here are some activities that we have took in during the pandemic, and these activities was very much likely by all of the students and teachers. We took this in the various types of teacher training programs also, and teachers love this activity because no special things needed for to perform these things. Okay, so we will start immediately. So first thing is the Leidenfrost effect. We first of all, I seen this effect when I was introduced, or we can say when I first see the liquid nitrogen experiments. So during the liquid nitrogen experiments, I have seen this kind of effect, that when the liquid nitrogen drops are falling on the surface or any surface, that drops are we can say pivot on that surface, or rolling on the surface. So I think that why this happens. So can I explain this experiment, or can I perform this experiment in my house without using liquid nitrogen? So this is a nice example, that the Leidenfrost effect is nothing but it's a physical phenomenon in which liquid close to surface that is significantly hotter than the liquid's boiling point. So when any surface is very hot than the liquid, then what happens? It produces an insulating vapor layer that keeps the liquid from boiling rapidly. And then what happens, that the drops of the liquids we can say levitate on that surface. Okay, so this is because of the repulsive force. Droplet hovers over the surface rather than making physical contact with the hot surface. So I have took this video, I recorded this video. So you can see, first of all, I have poured some normal temperature water on a simple aluminum metal pan, or you can take any kind of metal pan or pot, and just you have to keep it in a normal temperature, or we can say a room temperature. The first thing is that your liquid and that metal pot should be at the same temperature, or we can say room temperature. And after the second stage, when you have to learn about Leidenfrost effect, you just have to heat that pot, okay, and then again pour the liquid. Then you can see the difference, the actual difference. So you can see a video here. I will make it in a full screen. So can you see the video? Yes. Okay.
Yes, we can.
You can see I am putting normal temperature water. This is the water. This liquid is normal water in a metallic pot, so which is not heated yet. Okay, so you can see that the pot gets wet during this process, which is a very normal to see. And now I have heated that pot using a gas flame, and you can see that when I pour some normal temperature water, so the Leidenfrost effect took place. Okay, so this is a very simple thing, and we do all these things regularly, okay, in a daily routine, but we can't observe in a scientific way. So now, as we are in the home from yes, as we are in the home from many months and from since last 2 years, so we should look or we can observe these things which is happen in daily life in our houses. So this was a Leidenfrost effect. You just have to, when you need some water, okay, or any pan, any metallic pan, it may be an iron pan, maybe aluminum or steel metal pan, and you just need anything to give them heat. Okay, so this is a Leidenfrost effect. You can do it at home. Then this is second thing, that is we study properties of light in our school days, and also the advanced light properties in our college days. So our first properties of light, we learn that simply the reflection and refraction. But for this, we need different kinds of laboratory material that we need laser. So I have used here laser, which is not easily available in the market, but you can take any small red light laser, which is having not so much cost. Okay, and you can get in any kind of small market or any shop, or you can use just any stick, okay, wooden stick, and instead of laser you can put in that glass container. Okay, so you can do it this thing by using any kind of stick also. Okay, and in this this is a tungsten bulb actually, but you can take any glass, transparent glass bottle, okay, or which it should be a flat in nature, just like this. Okay, it should be a flat in nature. But in India, mostly this kind of bulbs are used, and when they get damaged, all people throw it away. Okay, all these bulbs. So instead of throwing them, because these bulbs having very nice shape, and they are very good transparent, so I have used this for demonstrating this reflection and reflection phenomena. So most of the time in classroom, what happens, we just draw these diagrams and teach students about the reflection and refraction, and later on students get bored with this all kinds of ray diagrams. So when you show such kind of experiments, you can see that in pictures it looks very attractive also. So you can learn this kinds of properties of light, or any optics related phenomena using this simple material. So here is a bulb. You can take any bulb. Here from this cap of this end, you should have to drill that bulb. Okay, or you can have to you should have to remove that end. Okay, so from there you can put some water inside that bulb. It should be half filled. Okay, and 2 drops of any antiseptic liquid like a Dettol, or you can say Savlon. You should have to put 1 to 2 drops. This is because of you should get a better visibility uh, due to scattering of light, laser light beam. Okay, so you should have to put some 1 to 2 drops of antiseptic liquid, and then in the upper portion of this bulb, you should have to put some smoke. Okay, a little bit smoke from any wooden material. You should have to put some smoke, and you have poured some 1 to 2 drops of antiseptic liquid. That's why in the both portion you can see easily the laser beam. Okay, so that's why we are doing this thing, and then just you have to take this laser from this side and put on this glass container. Then you can observe the beautiful refraction of light beam. Okay, from now the first image is from water to air. Okay, then this second images of reflection of light. We also called it as a total internal reflection of light. Okay, so this is a nice video. You can see in this video. So this is a glass container. First of all, I put laser beam from bottom, and then just take that laser upwards. Then you can see the reflection of light. Again, take little bit down, then you can see the reflection of light. So both the phenomena you can observe in this small experiment. And I made this video on the occasion of the International Day of Light, and put on media. So this is a bulb ray model, but if you don't have any kind of bulb, you can take any kind of glass flask, transparent glass flask, and you can perform this experiment, whatever available at your home. Okay, so there is no need of any kind of standard conical flask or standard glass flask, which is available mostly in your laboratories. Okay, school laboratories. There is no need of this. Okay, just you need a special thing, that is a laser, but you can use a very easily available or very cheap laser to perform this experiment also. So I think everyone understand these things.
I think if the audience has any queries, please feel free to interact with Rupesh whenever required. And I think these are wonderful models to be getting science in the homes. So yeah, if the audience has any queries, you can ask. Otherwise, Rupesh can continue.
Yeah, I'm continuing. If you have any queries, we can discuss at the last also. Okay. So this is another very important, we can say, very important device that in these days we require, because from 2 years we are with our Android cell phone, and we are performing various types of activities, that is taking lectures and attending the sessions. Okay, doing some presentations and word file, paint file on our mobile, because mobile, or we can say cell phone, in rural areas, mostly all the students and most of the teachers don't have any kinds of laptops and computers, so they mostly use mobile, and we can see that the mobile screen is very small, and if they want to do some or sketch some drawing, so they're facing more and more problem. Okay, so that's why we decided to make some small device, that is, we generally call it as a stylus. And how we can do this stylus using very low cost material. So I think this stylus cost only 2 Indian rupees. Okay. So we have used old pen. Okay, this is an old pen, we can say ballpoint pen, which having a refill inside it, or we can say ink tube. We should have to remove that tube, and just you need this. This paper is nothing but our aluminum foil. I will tell you the reason behind these things. Okay, this is aluminum foil, and this is nothing but a cotton bud, simple our cotton bud. If you have a cotton, you can make a small bird from that, or you can uh, use these cotton buds to clean your ears. That cotton buds you can use here also. Okay, so you have to just put this cotton buds in front of the pen. Okay, insert here, and then wrap this aluminum foil where you are holding, the area where you are holding this pen. Okay, so your finger should be touched to this aluminum foil. Okay, and then just dip this cotton bud in, or you can put some water drop on this cotton bud that easily get absorbed by cotton, so cotton becomes wet. Okay, and then you can use this homemade stylus for your operation. Also, here is the video. So you can see the sensitivity is very much high in this device also. So we know that how stylus works. So while doing this experiment, we can tell students to how this stylus works, or what is the working principle, or what is the scientific concept behind this. So we can have both things, that is the science behind this small model, and use of the model is more. Okay, so we know that our fingers having a static charge. So when we touch to any kind of touch screen, okay, so that due to that static charge, we can do all the operations of selection and moving all these things on the screens. So we took this concept here also. Okay, so the aluminum foil is, we know that it's a good conductor of electricity. So that foil takes charge from our fingers, and that charge will go towards the this tip of the cotton. Okay, and then through that it goes to the screen. So as we touch this pen to the screen, the operation perform as same as your fingers do. Okay, so this is a homemade stylus. Okay, so you can do it in a large quantity. Okay, you can ask students to do it. They can make these things in just 5 to 10 minutes. Okay, so these are the good experiments, and which are very much useful during this pandemic also. So this is the homemade stylus. Then the another thing is gyroscopes. We all are familiar with the different kinds of gyroscope. So a gyroscope is nothing but device used for measuring or maintaining orientation and angular velocity. So it is a spinning wheel. We can see here. It's a this is a normal diagram of a gyroscope, in which we can see here. This is a rotor. Then this is called as a gyroscope frame. Then this is a spinning axis, and this is called as a gimbal. So we can make such gyroscope using a household material. We know that this gyroscope using a CD, which is not used where this kind of gyroscope used. Okay, but we know the various kinds of application in communication, in aircrafts, in various kinds of ships to navigate. All these gyroscope things are used, and we know that the digital, or we can say electronic kind of gyroscopes is in our all cell phones are there. So a student must understand the scientific working of this gyroscope. Although us all students mostly come to school using their bicycles, on their bicycles, but in the pandemic everything is stopped. So they are not using the we can assume that they are not using their bicycles, but we can ask them first a question that when your bicycle is stopped or not moving, then it gets fall. Okay, and when it is moving, then it doesn't fall until you fall or you can say any object is coming in front of you. Okay, so the reason behind this we can explain through this small experiment. It is called as a CD gyroscope because we have used CD and simple thread. Okay, and this is a piece of any kind of wooden stick, or you can take a plastic stick. Okay, and then just tie this plastic stick to CD using this transparent stick tape, and attach this string to that stick. Okay, and just hold like this and rotate that disc with your another hand. So you can see that disc, whatever angle you have given during the rotation, that angle remains the same. So what happens in our daily life when we drive any kind of two-wheeler motorcycle or any you can say bicycle. So when that bicycle or motorcycle is in the motion, and the particular kind of vertical angle you have took, so your both the wheels, front wheel and back wheel, acts as a gyroscope. So gyroscopic forces are there. That's why you can't easily turn right or left. Okay, and also you can't fall during when you are in motion. Okay, so you can explain through this. And there is a I asked to bring this material for this workshop. So if you have this material, just look at this diagram and just attach all things like this. And here the video of another kind of gyroscope is there. So in this gyroscope, I have used some spinner, which is a toy for students. Mostly we called it as a field gauge spinner. So field gauge spinner is used and it is attached to CD. Okay, simple compact disc, or you can say DVD. And then you have to perform the experiment which is shown in this video. You can see. So this is a CD. Now you have to rotate that spinner. Then you can see that as the spinner is rotating, your CD becomes vertical. Okay, it doesn't fall. So when your spinner gets stopped, then the CD will fall. Okay, so that's why when you are on your bicycle and moving, you doesn't get fall. Okay, so this is due to the gyroscopic forces and the particular angular momentum. Okay, so you can introduce the various concepts in science like angular momentum, gyroscopic force, gravity. Okay, all kinds of these things. Okay, and also how modern rockets and modern projectiles, also aircrafts and ships, use this concept to navigate. Okay, you can explain these things by using this simple toy. So this is about gyroscope, and I took a 2-hour-long session for college students, mostly, or for teachers, only on gyroscopes, all kinds of gyroscopes. Okay, there are various types. You can start from your mobile also, or you can say cell phone. It's also having modern cell phones having they are having a gyroscope. Okay. Now, another thing. So, stethoscope. So, in these days, we are more familiar with this device, that is stethoscope. Mostly, when we visit to a doctor or family doctor, then he just wearing that stethoscope, and mostly children are more curious about that, because they want that stethoscope, and they want to hear how doctors listening our heartbeats. Okay, but we know that doctor don't give them easily. Okay, so that's why we can't make this from our household material. So I don't know in other countries this material. I don't know the particular name for this material. So in India, we call this triangular plastic shape as a funnel. We need a small funnel, and this is a transparent plastic tube. If you don't have any kind of transparent plastic tube, if you have a opaque, then it should be fine. Okay, but it should be a smooth like a plastic material. Okay, if you have a rough surface, or you can if you have a rubber tube, then the efficiency of your stethoscope becomes very low. So, and here at the bigger side of your funnel, you should have to put balloon. You have to cut balloon piece and then attach like this in the as shown in the second image. Okay, and here this is earbud, okay, which is in our you can say earphones. Okay, small earphones. So if you attach this to that plastic tube, then you can the noise cancellations will be there. Okay, better. So you should attach here. Okay, and now you can listen your heartbeats clearly. So you can count your heartbeats per second, per minute. Okay, and perform various kinds of experiments. So you have to just do this. So first of all, you should do this experiment while attaching your funnel to the right side of our heart, our chest. So and then try to listen. You can't listen anything. And when you put on the left side, you can listen your heartbeats clearly. So once again, you can start with this. Okay, this activity that is our on which side our heart is present, right or left. On right side, why we can't hear the heartbeats. Okay, and also the properties of sound exactly same like properties of light, that is reflection is there. Okay, so multiple internal reflection happens in this stethoscopic tube, and then we can listen this sound carefully. So you can perform this experiment by removing that balloon piece, and then once again you can do this experiment. Then you can understand the importance of that balloon diaphragm attached to this stethoscope. And it's a health related model, so everyone can do, and first of all play with it and then learn some science. Then the experiment is a sound pipe, that is a proper, again it's related to properties of sound. So most of the most of the classes where I visited, when teaching topic like a sound, most of the teachers, what they do, they just wrote on textboard, sorry, whiteboard, or we can say blackboard, the definition of the sound, all the diagrams, or blah blah blah. Okay, whatever things, but they don't produce sound in the classroom. Okay, so we told them how we can feel this sound, or we can observe the this sound using our ears, or feel. So we decided that instead of just making a noise, we can do some experiment, and we can design some simple models. So in this model, we just took a small transparent straw, or you can take any rigid pipe. Okay, it is not mandatory that the pipe should be transparent. Okay, but if you take a transparent pipe, then you can perform more and more experiments related to properties of sound. So just attach a small balloon at any one end, open end of that pipe, and then tie with rubber band or string, and do this same experiment as I showing in the video. So you should have to fill this tube up to here with water, colored water. You can see that as I'm increasing water level, so if there is a rise and fall of water level, then you can see there is a change in the sound frequency, or you can see the sound tone. So how this tone changes, or what is the relation between the height of the water level, or height of the empty tube, and um, tone of the sound. Okay, so you can find out the relation. You can prove some equations like frequency is inversely proportional to wavelength of the sound. So you can prove all these kinds of small equations related to properties of sound with the uh, such small models, which is having a very low cost, or you can make it easily through your household material. Okay, so this is a we called it as a sound pipe experiment. So thank you. So these are the some experiment I have selected for this workshop. So as I just go on my slides, so I don't know how much of you brings the material here, and how much time we remaining.
I think we have almost about 15 minutes, Rupesh, 15 to 17 minutes with
Okay,
us.
so we can discuss.
So I already see a few questions in the chat box. So this was a wonderful presentation of almost about 6 different experiments which you took us through, and gives us a lot of ideas how to conduct activities at home. And I do strongly believe that each home is a laboratory. So I think we all have a lot to do. So getting to the first particular activity which you shared about the Leidenfrost effect, I very much can relate it to the thought of a dosa, which we all have, like a pancake. When you are making the pancake and you just put in warm water, and you can directly see this effect, and it's such a great realization. We do this every day, but we really have not brought it into learning. So I see a message from Adriana for your model of bulb ray model. So she types that is the antiseptic liquid only for giving the color to the water.
Not for giving a color. Your light beam should be visible, easily visible. If you don't put that antiseptic droplets, then the scattering effect does not takes place effectively. Okay, you just you can't clearly see that light beam. Okay, laser beam in it. So for visibility, we use this, not for to give color to the water.
If there are any questions for this particular model, you can ask him, or if someone wants to raise a hand and comment on this particular idea, you can just raise your hand, or we can move to the next one. There's also a comment by S.N. Iyer mentioning that this reflection and refraction experiment is a fantastic way to learn about the behavior of light and different mediums. So I think we can, as you shared already, that we can experiment a lot using different materials, like even using a bottle or a cup or covering it. We need to just capture the smoke inside. So I think that's interesting. So Amit Raka mentions that antiseptic is used to make water translucent, you mean, or that is more easily visible?
Yes, yes.
So it makes the water a bit more translucent, not completely transparent. Okay. And could we use also milk then?
Now I don't have used the milk. Okay, so I don't know how much it will be effective to, but you can try. If there is not available, the antiseptic liquid is not available, then you can try different kinds of colors, or not the dark colors, but light colors you can use, but just a little bit, 1 or 2 drops, not more than that.
Okay, I think we cannot use milk, but we can give it a try, like
Yes,
putting
yes,
1 or 2 drops. I think science is about experimenting, and I think that's the fun of it. So I think you can give it a try using milk, a few drops of milk. So we can also go to the next model where Adriana asks if is the tip just of cotton used as a FOIC, which is frame input output controller, right, Adriana?
yeah.
So is it, what is the purpose of the cotton tip? Yeah, so that's something what Adriana asks. Yeah, Rupesh, are you there?
Yes, yes, yes.
Um, so what is the she's it's is the frame of the tip is only used for the tip of cotton is used only as a frame input output controller.
Yes.
So it
Yes.
so that I think he already shared the science behind it in his presentation. So I think that can have some relation to what he's saying. Adriana, is it clear, or if you want to have a conversation with him, you can try and have a conversation. I think you can put your mic on and ask him that detail if required.
Do you hear me?
Yes,
Yeah.
yes.
Yeah, yeah. I want to know if I have to put some dot of cotton on the tip.
Yeah.
Yeah, only one top with some water, some drops of water.
Yes, yes. Some drops of water.
Oh, okay. Thank
Just
you.
you have to wet that cotton tip. So your the static charges from your fingers through this aluminum foil easily touch to the screen, and
Okay.
the screen becomes works.
Okay, you're a genius. Thank you so much.
I think there are lots of indigenous techniques how people have found in our country. So I think this is a very interesting model, and just using two rupees, which is I think minimum cents, even not a cent or something like that, I would say. Okay, so going to the next one is basically if there are any questions for the gyroscope, if anyone has any questions, you can post it to Rupesh, or else if there are no questions, we can move to the next one. No, I think Rupesh, there are not many questions for the gyroscope.
Okay.
Yeah, so we can. I think we have stethoscope. I think as kids we have always played with this, but what I found special is understanding it with the balloon on the second side. So I have always used the funnel, and we have tried to hear it not having the balloon on the second side, but I
Yeah.
think that's the difference which we can learn about. So if anyone has any specific questions, you can raise your hands. If there's any conversation you would want to make regarding this, you can try to yeah, put it forward to Rupesh. Or is anyone? I think no. So we can go to the last one of the sound pipe. Uh, I think Rupesh, I can really relate with a bird which I have
Yeah.
been playing with, a traditional bird which we find in our country,
Yeah.
and which has water filled in it,
Yeah.
and you whistle through it, and it's really the same kind of experience. Just a thought, Rupesh. It would be really wonderful if you can share your presentation, and even if you can put in 2 or 3 liners for each experiment,
Yeah.
so that the participants can know and perform these experiments at their homes. It would be really wonderful for each participant. So I think
Okay.
that's pretty much from my side. There are some wonderful comments from members in the group. So you might want to just read through it and flip through them and enjoy the time.
Yeah.
If there's anyone from the group who wants to make a conversation with Rupesh, please raise your hand and you can have a word with him. And you can also write to him on the email address which he has shared here.
So this is our official email address, where you can write questions related to basic astronomy, advanced astronomy, related to telescope. We also do a telescope making sessions also, and the basic science experiments and the sky watch and all things. So you can write to us for any kind of query related to that.
Yeah. So thanks a lot, Rupesh. If we still have few minutes, like
Yes.
5 minutes, and if there's anything more you want to share, otherwise we can
Yes,
even
yeah, I can explain that model also, which is now running on the screen.
Sure.
So this is a simple CD top made by using the CD. Okay, and I have put a print of such pattern. There are only dot of bigger dots are here, then smaller, and then smaller. So I took a circular print and stick to that CD. And just for a rotating purpose, I just attached using a glue, that single marble. So and I recorded this video in a slow motion. So when you record this in a slow motion, you can see a beautiful pattern. And now you can think about why this kind of patterns we see, that some dots are rotating in a reverse direction, then some are in a forward direction. Okay, so you can think about it. So this phenomena is related to persistence of vision. So it's illusion kind of concept related to our brain functions, brain and eye functioning. So we know that there is a particular time required to see some object and receive that signal or transfer that signal to our brain. So if something is happening in front of our eyes faster than this time, then we see all this thing in a continuous pattern. So all kinds of animated movies and all kinds of, we call it as a video, but we know that there is no actual video. It's also photographs. Okay, took in a very higher frame rate. Okay, and when we play with particular speed, then we can see this motion picture. We call it as a motion picture effect, and this phenomena is due to that.
Rupesh, can you zoom in this video? That's what I get in
yes,
the comment.
okay, yes. So you can take prints of various kinds of patterns and attach to that CD, and you can observe the fabulous effect after that. So this is recorded in 120 frames per second in a slow motion.
This is really interesting.
So now you can see that the speed is very slow. That marble is very, you can observe through this marble, but you can see that there is a different speeds of each and every circle. Okay, and in different directions. So these kinds of model, which are very low cost, looks attractive, that initiates or triggers the inspiration in the children's to perform such kind of experiment towards science. Okay, so we always request to teachers that use such education related experiment while teaching. So your teaching becomes more and more attractive.
Just a question, Rupesh, that does IUCA have a kind of an online resource for such kind of activities to conduct at home?
Yes.
Is there some, where do you put it? Can you share it with the group or something?
Yes, we have our Facebook page, YouTube channel also, where we mostly do these videos, online lectures, trainings, live on this our channels. So just tell me where I can share these things, all these things.
You can share this your YouTube channel in the chat box just now. You can also share your website in the chat box just now. Also, the presentation, if you can share it with Gustavo, they can further share it with the members if required, because it's a very interesting thing, and not everyone would have really been doing it hands-on, but it would be great that everyone can use this resource for the students and the communities. It would be wonderful.
So I have shared our website. So all the links related to YouTube channel, Facebook channel, all the things you can find on this website also, saipop@iuka.in.
It's is it a website or email address? It's a website, is it?
Yeah.
Okay. Great. So if we are done with the interaction, we might want to end the session a bit early. And thanks a lot, Rupesh, for this wonderful presentation, this wonderful idea which you have brought in everyone's mind. I would love to work on these ideas with my students, and looking forward to connect with you very soon. So I would now hand over this session to Fraser, but we are going to have a short break before that, and so request all the members to have some coffee, and Gustavo, you can put a break for a few minutes. Gustavo Aviva.
Yeah, it's me. I have to allow the screen sharing.
Okay.
Be right back. But we have a 10 minutes break now, and we'll be right back.
Okay, great. So after the break, we'll have Fraser, who will be introducing the next presenter. So looking forward for this wonderful workshop. Thank you. Thank you, Gustavo, for allowing me to chair the session. Thank you, Rupesh.
You're very welcome. You're excellent, chair. And thank you, Rupesh, for the presentation.